I've been doing a lot of video recording with amp hours written up in the top of the board. Amp hours is the unit of measurement used to indicate how much power a battery supplies or contains. It may be 9 volts, it may be 12 volts, as in this example I've drawn at, but if you've got 6 amp hours, it's a lot more powerful than a 3 amp hour. So 12 volts times 3 amp hours means it delivers 3 amps for 1 hour, delivers 1.5 amps for 2 hours, delivers 1 amp for 3 hours, delivers 3/4 of an amp for 4 hours. You've got the idea. 3 1s are 3, 1.5 times 2 is 3, 1 3s are 3, 3/4 times 4 is 3. There's that magic number. That's your amp hours. We know power is volts times current. So the power here, instantaneous, is 36 watts for that hour while it's delivering charge. Power is the rate of doing work. You're doing 36 watts of work for 1 hour. 36 watts per hour. 1 watt is 1 joule per second. So that means that 1 watt per hour delivers 3,600 joules. Why? Because there's 60 minutes in an hour and 60 seconds in a minute equals 60 minutes in an hour times 60 seconds in a minute equals 3,600 seconds in 1 hour. So 1 watt hour is 3,600 joules. Let's say we've got a HSC question. This battery, 12 volts, 3 amp hours, is providing power to an electric hoist lifting something up at 80% efficiency. So now I'm working at 80% efficiency. The total available energy to the hoist is 36 times 0.8. So it's 36 minus 7.2 is 28.8 kilowatt hours equals useful energy. But as you know, watt hours is an archaic form of how to measure energy. We use joules. The conversion, 1 watt equals 1 joule per second. 1 watt hour equals 3,600 joules. That means the total energy I've got is 28.8 times 3,600. 36 times 28.8. I'm just too lazy to go over there and get a calculator. So 28.8. So 28.8 times 3,600 is, adding the 2 zeros, coming back 1 decimal spot, it's 103,680 joules. 104 kilojoules of energy I have available to me to provide useful work.